Welcome to the debate. So picture this. You walk into a modern convenience store, right? You want to buy a rice ball.
Simple enough.
Exactly. But you don't stop at the entrance to read uh, a 100-page operational manual.
Right, nobody does that.
You don't need a specialized training seminar to understand how to open the fridge door, grab the item, and pay. The environment itself, like the physical layout and the UI constraints, it just flawlessly dictates your actions. You just do it.
Well, it's a beautiful, seamless experience. But if you've ever actually stepped onto a factory floor, you know it is decidedly not a retail shop.
True. It's highly pressurized, it's messy, it's intensely physical. And when you try to impose that kind of invisible digital system onto heavy manufacturing, it often feels less like a guiding hand and more like, well, an invisible brick wall, especially without a human there to translate the digital system into physical reality.
And that fundamental tension is exactly what we are exploring today. Our central question focuses on the most effective strategy for implementing digital transformation, or DX, in a traditional manufacturing environment.
Right.
When transitioning a legacy factory floor into a digital powerhouse, does success lie in designing foolproof, invisible systems that dictate action, or does it require building specialized human translation layers to bridge the gap between high-level IT strategy and, ground-level physical operations?
It's a fascinating problem because it forces us to bridge software engineering, organizational psychology, and raw industrial mechanics. I mean, you can't just write code, right? You have to deal with physics and actual human behavior.
Precisely. And this discussion emerges from a comprehensive case study detailing a manufacturing company's intensive, multi-year effort to digitize its operations. We're looking at their deployment of some pretty sophisticated automated infrastructure.
Specifically, their proprietary tracking system they call Freya, the integration of AI agents for back-end workflows, and the shift toward paperless video manuals.
Yeah, yet alongside these massive technical triumphs, their internal deployment logs documents profound adoption resistance and friction on the floor, which sets up our debate.
Where the rubber meets the road. It's one thing to design a system in a boardroom, but it's another to ask a worker in safety gear to actually use it.
Exactly. Now, I will be arguing for the system-first approach. My position is that true digital transformation means redesigning the user interface and the back-end infrastructure so comprehensively that workers are guided flawlessly without ever needing to adapt their behavior.
The convenience store factory concept.
Right. The system absorbs the complexity.
Well, I'll be taking the human-centric approach. I maintain that without a dedicated, specialized human translation team to mediate between that top-down IT strategy and the daily realities of the factory floor, even the most advanced, expensive systems will ultimately fail. The system alone cannot enforce adoption.
Let's lay the groundwork for my position. Digital transformation at its core only succeeds when the system entirely removes the cognitive load from the worker. Traditional manufacturing relies on training workers to be perfect, right?
Yeah, forcing them to memorize incredibly complex standard operating procedures.
Exactly. The system-first approach flips that completely. It embeds those standards directly into the equipment UI and the data systems. Think about how the Freya system operates in the material.
They aren't just putting iPads on workbenches.
No, the system is wired directly into the logic controllers of the legacy machines. If a worker scans the wrong barcode for a batch of materials, the system triggers a relay, and the machine simply will not physically proceed. It locks them out.
Right, a hard stop.
Yes, true DX eliminates the need for human behavioral change by automating workflows entirely. The goal isn't better training, it's structural invisibility, where mistakes are systemically impossible.
I understand the allure of that vision. I really do. It sounds incredibly clean on paper, but my position is that digital transformation fails without a dedicated human translation layer.
Because of the friction?
Because top-down systemic rollouts fundamentally ignore the psychological and physical bandwidth limits of factory workers. The internal report we're looking at is highly transparent about this. Even with this brilliant Freya system installed, workers were continuing to jot down defect numbers on scraps of paper instead of logging them into the touchscreens.
But why rely on paper when the screen is right there? It doesn't make sense.
Because taking off your protective gloves to navigate a touchscreen while a heavy machine is running next to you is a massive physical disruption.
Ah, okay.
We also saw floor leaders skipping vital IT implementation meetings because they were tied up fighting real-time production fires. A sophisticated system is utterly useless if the workforce is too overwhelmed to engage with it.
So they need people to translate it.
Exactly. The organization explicitly had to restructure to solve this exact bottleneck. They separated the strategy team, who looked to the future, from the tactics team, whose entire job was to act as translators for the floor. That structural shift proves that human mediation is the actual driver of digital adoption.
I see how that friction looks like a failure of the technology, but let me reframe that. The friction isn't proof that we need a permanent human translation layer. It's proof that the system's user interface hasn't reached its final invisible state yet.
How so?
Well, let's look at the core of the convenience store model. The company realized that traditional paper manuals are completely obsolete. By integrating digital instructions directly into the Freya UI and utilizing video manual platforms like Dubiki, the system inherently ensures quality control. Think of it like a modern smartphone operating system.
Oh, I have to stop you right there, because that smartphone analogy is exactly where these IT rollouts go wrong. I come at it from a different way.
Hear me out. You don't need to understand how a smartphone's kernel works or read a manual on memory allocation to use it perfectly.
Sure, but
The constraints of the UI prevent you from breaking the device. In the factory, if the QR code on the raw material doesn't match the digital work order in the cloud, the machine's physical start button is dead.
Right, the hard lockout again.
Exactly. The worker doesn't need a human translator to sit them down and explain the overarching corporate strategy of quality control. The UI simply constrains their reality so that only the correct action is possible.
The smartphone analogy is conceptually neat, but it completely collapses on the factory floor.
Why?
Because when you are using a smartphone, your primary task is using the smartphone. You're sitting on a couch. On a factory floor, the worker's primary task is managing heavy machinery, handling sticky adhesives, and keeping a highly volatile physical production line moving.
Okay. Their hands are full.
Their physical hands are completely full. The case study highlights a glaring reality. Even with the Freya system installed, workers aren't eagerly checking the digital dashboards. They aren't clicking approve on digital workflows.
But the system's designed to quantify and remove that volatility.
In theory, yes, but let's talk about practice. The assumption of 100% systemic control is a myth when a human being is actively managing a dynamic physical process. What happens when a worker encounters an edge case?
Like a torn barcode?
Yes, a torn barcode that the scanner can't read, or a slight material variation in the plastic that requires a different heat setting. That invisible UI constraint you just praised suddenly becomes an invisible brick wall. The machine won't start, the worker doesn't know why, and production halts entirely.
Which is a system design flaw, not a lack of humans.
It's exactly why the tactics team, the human translators, are non-negotiable. They explain why the data matters in the context of their specific physical task. Without that human empathy bridging the gap, the UI is just an unyielding barrier that frustrates the floor.
I agree that edge cases cause frustration, but the resentment stems from the transitional phase. It's where the legacy physical process hasn't been fully mapped to the digital one yet.
It's a long transition then.
Sure, but the physical UI is just the skin of the factory. The resentment really starts when we look at the nervous system, which is the back-end data processing. And this is where the efficacy of automated workflows and AI agents comes in.
The back end is definitely where this gets incredibly complex.
And incredibly powerful. The internal report details a massive deployment of AI agents to handle the cognitive heavy lifting. They're using AI models to automatically summarize meeting notes, manage schedules, and organize files.
Right.
But it goes beyond admin work. Look at the vision they lay out for predictive ordering. They reference how Lawson convenience stores use AI to predict rice ball sales based on local weather patterns and demographics, completely removing the store manager's daily ordering task.
And the factory wants to do that with adhesives and cardboard.
Exactly. Weight sensors on the adhesive vats linked to Freya, pinging an AI agent that cross-references upcoming production schedules and automatically emails the supplier when stock is low.
No human procurement manager.
None. No manual inventory counting on a clipboard, no forgotten orders, Total automation proves that human intervention in these workflows isn't a necessary translation layer, it is fundamentally a bottleneck.
Okay, total automation sounds fantastic in a PowerPoint presentation, but I am not buying it as a reality for these workers.
Why not? The tech is there.
Let me tell you why. You're looking at the theoretical ceiling of the technology while completely ignoring the psychological reality of the people subjected to it. The deployment logs practically scream about a phenomena we all know too well, which is tool fatigue.
Tool fatigue is just a symptom of poor software integration.
It is a symptom of human cognitive limits. Let's break down the actual software stack they're juggling in this case study. We aren't just talking about Freya.
True, they had a lot of tools.
They introduced Judo for task management, Noda for voice transcription, Tabiki for video manuals, Chatwork for internal messaging, Japanese legacy groupware like Saibozu for scheduling, plus the Freya dashboard for production tracking.
That's a lot. Yeah.
You're expecting a worker covered in grease, whose primary metric of success is physical output, to context switch across half a dozen platforms. The internal data explicitly admits that many of these tools ended up being practically abandoned.
Right.
You can drop the most sophisticated AI agent into the network, but if you don't have a human tactics team to curate these tools, to introduce them at a digestible pace, you don't get digital transformation. You just get digital clutter, a graveyard of paid licenses.
I will easily concede that throwing half a dozen disconnected tools at a workforce and walking away is malpractice. It creates chaos.
Exactly my point.
But the solution to that chaos isn't to hire more human translators to handhold people through bad software architecture. The solution is deeper back-end integration.
How so?
The case study actually points toward tying these platforms together via APIs. The complexity shouldn't live on the worker's screen. You have Nada transcribe a meeting, an API pushes that transcript to an AI for synthesis, and the AI automatically dumps the actionable items into Johto while updating the Seibozu calendar.
So the user never has to switch apps?
Exactly. The complexity is hidden in the back end.
But hiding the complexity in the back end doesn't solve the fundamental issue of data utilization on the actual factory floor. And this is really the crux of our disagreement.
Okay, let's hear it.
Let's move from the software stack to the physical output, specifically real-time defect rates. The executives are sitting in an office, looking at the Freya dashboard, and seeing that the O's factory generated 234,000 yen worth of scrap in a single day.
Which is an incredible level of visibility. Historically, that scrap data would be manually written on a clipboard and lost in a paper binder for a month.
Absolutely. The visibility is unprecedented. But here is the catch, and it's a big one. Visibility is not intervention.
What do you mean?
The internal report uses a brilliant, highly specific analogy. Factory data is highly perishable. Just like an ER doctor tracking a patient's vitals, seeing a dropped heart rate on a monitor an hour after it happens is useless. The profit margin is bleeding out in real time.
Sure, you need to act fast.
But you cannot ask an ER doctor to run the blood centrifuge, analyze the chemical results, and perform the heart surgery simultaneously. It is physically and cognitively impossible.
Go on.
The factory worker is the surgeon. They are actively operating the line. They cannot be expected to stop their physical production, take off their gloves, log into the Freya dashboard, analyze the fact that the 4TD part has a 20% defect rate, deduce the root cause, and formulate a systemic fix on the fly.
So you're saying,
because the worker is busy doing the actual manufacturing, you absolutely need a specialized human role, a tactical translator deliberately separated from the daily production quota. Their entire job is to watch the monitors, walk down to the floor, and say, let's pause. The 4TD part is failing. Let's adjust the clamp.
That's an interesting point, though I would frame it differently. I hear you on the ER doctor analogy, but I actually think it proves the exact opposite point.
Really?
Yeah. I don't disagree with the premise of perishable data, but I draw a completely different conclusion. You are arguing that because the surgeon is busy, we need to hire a separate, dedicated nurse to stand there, read the monitor, and tell the surgeon what to do.
Essentially, yes.
I am arguing that the monitor itself should automatically trigger the intervention.
How so? The monitor doesn't have hands.
No, but it has API access to the machine's control logic. The necessity of a human data analyst walking down to the floor to tap someone on the shoulder is merely a transitional phase.
It's a band-aid for an incomplete system.
A Band-Aid?
Yes, the case study explicitly points toward a future where the AI agent doesn't just passively display that 234,000 yen scrap rate on a dashboard. The system analyzes the 4TD defect rate in real time, identifies the statistical anomaly, and then it automatically triggers a machine halt via the PLC relays.
That's a massive leap.
It locks the equipment out of further production to stop the financial bleeding instantly, while simultaneously scheduling an intervention in the floor manager's calendar.
You are placing an immense amount of faith in a cloud system's ability to understand the physical context of a factory floor.
It's not about faith, it's about mechanism and causality. We already established that if the barcode doesn't match, the machine won't run. The exact next logical step is that if the defect rate exceeds a 2% threshold over 10 cycles, the machine won't run.
But
The ultimate goal is systemic supremacy. The system can calculate the loss and halt production infinitely faster than a human translator walking across a noisy factory floor.
That is a highly sanitized Silicon Valley view of industrial reality. Halting a machine programmatically based on a data threshold sounds amazing until you realize that a 20% defect rate might be caused by a slight humidity change in the room affecting how the adhesive dries.
Okay, but
Wait, let me finish. The floor worker, the human being with 20 years of experience, knows how to compensate for that manually by adjusting their application technique if they're allowed to keep the machine running. If the system auto-locks the machine without understanding the physics of the room, you've just paralyzed production over a solvable physical nuance.
But physics can be quantified. We can install humidity sensors. We can model those variables.
Modeled, yes, but not always predicted with 100% fidelity. The physical environment is simply too dynamic. When you impose rigid, autonomous systemic control without a human translation layer to interpret it, those digital tools quickly transform from solutions into massive burdens.
I see where you're coming from, but doesn't that just coddle the legacy mindset?
Not at all.
If we constantly provide human translators to buffer the workforce from the technology, we never force the cultural shift required for true digital transformation. We just end up paying humans to be a patch for legacy habits.
It doesn't coddle them. It respects their operational reality. You cannot mandate a cultural shift from a dashboard, and you can't enforce adoption through software lockouts alone. You have to earn it on the floor, person to person.
Well, let's pull back and look at where this leaves us. My position remains that the highest form of digital transformation is structural invisibility.
Right.
From the intuitive UI constraints of the Freya system to the automated back-end data processing, the goal is to build systems so robust that the need for human behavioral adaptation, and yes, human translators, is engineered out of existence. The system dictates the success.
And I maintain that this view deeply underestimates the chaotic physical nature of heavy manufacturing. A factory is not a closed digital loop running on a server. It is an open system of raw materials, heavy machinery, and human psychology.
A messy reality.
Very messy. Without a specialized, dedicated human translation layer, the most advanced software stack in the world will simply be ignored. Digital tools only generate value when human beings are guided, patiently and empathetically, on how to wield them.
I will say, despite our different philosophies, there is a clear area of convergence here. We both entirely agree that the era of the traditional paper manual is dead.
Absolutely. The status quo is indefensible. Siloed information, manual data entry on clipboards, forcing workers to split their focus. It's a recipe for complete failure.
The data visibility they have achieved with Freya is a monumental leap forward for the industry. We simply disagree on whether the ultimate solution is engineering the perfectly autonomous digital constraint or cultivating the perfect human infrastructure to interpret it.
Exactly.
Which leaves us with a profound tension to consider. This case study offers us a real-time glimpse into the frontier of industrial AI. It leaves us to wonder. The next time you walk into a convenience store and marvel at how effortlessly you were guided to your purchase, ask yourself, was it the perfect invisible system that made it so easy, or the invisible human labor that set the shelves perfectly before you arrived?
It's definitely something to think about.
Indeed.
There's much more to explore in this material, and we leave it to you, the listener, to decide which philosophy will ultimately drive the factories of tomorrow.